Avinash Shrimali. So he's a senior member of technical staff. He's working in a VMware in a R&D department since 2008. He has total work experience of 12 plus years, which includes virtualization, QA, development in Java, DevOps, security, SaaS, and open sources. So over to you, Avinash.
Thanks, Pooja. Let me share the screen. I hope it's visible.
Yes, it's visible, Avinash.
Okay. Hi guys. My name is Avinash, and as you heard, like I'm in VMware. Working in VMware as a senior MTS, and I hope along with me Ashwati is there today. I'm not sure she joined or not. So, anyway, um, I'm working in a group called Chaos Engineering Group in VMware, and Ashwati is like leading that effort. And we have been developing this tool for quite some time. We released 2.2, and right now working on the third version of the tool. So before getting into like what is Mangle, I'm not sure how like audience is comfortable with what is the concept of chaos engineering and what it is basically. So I'll just give a brief introduction about the what is chaos engineering. So uh, all right. So the, along with the other aspects of any application like security or performance, scale, and all these things, uh, resiliency is also one of the pillar for any software or any application which decides the how good your application or for a customer there should not be any downtime, and it always available, especially when we talk about the microservices architecture thing. So usually the SLAs and all are, we need to make sure that for customer there should not be any downtime. All right, so chaos engineering makes sure that you mimic the faults on purpose to your application before it goes to customer environment, and so that if the faults are there in your system, how your application behaves in such scenarios. So this is the basically idea about what is chaos engineering. So probably I can give an example. um, you guys must heard about the news. It was in last year, April 2019. The Air India server crash happened, and it it happened like around for like 6 hours. It was down, and more than 400 flights all over the world got affected because of that, and more than thousands of passengers got affected. Now this is a classic example where the fault happened to the server, and it did not took care well, or I mean, if it could have been properly taken care earlier, on not on the production environment before itself, if it should have been tested that in such failure condition, how the Air India server will should behave. So it should not have taken 6 hours to recover, a software glitch. So this is one example where you can understand like how what is the importance of chaos engineering in any of the application or the software environment. All right. So it's when we talk about chaos engineering, it's not only that like expectation is not that your application will not fail. I mean, you can try to avoid many things by like, for example, keeping a HA environment and a high availability, like, and high, very good bandwidth of network, and all these things you can have. But still, if the failures can come, which we might not be aware of. So any such condition, in any such condition, it's chaos engineering doesn't say that the application will never fail, but yes, in the failure cases, how your application behave, that is the most important aspect of that, and how it recovers once the failure is over. So this is the overall picture about chaos engineering. So we'll get into the slides for Mangle. So Mangle is the tool which we are developing in VMware, and basically it orchestrates chaos. It enables of running chaos engineering experiments seamlessly to access resiliency and fault tolerance. And this is the single tool for application and infra as well. So like you don't need the single tool will do for infra level fault as well as the application level fault. And now for the latest release, we have DB fault as well. So yeah, and we have it's been widely used in VMware, especially there are many organization in VMware who are currently using this tool. And apart from VMware, there are outside VMware also there are a couple of customers we have which are started using Mangle for their um, for resiliency certification. The deployment wise, we have containers which you can directly run as a Docker command, or you can run as a Kubernetes cluster. And we have OVA support as well. So you can deploy the OVA directly and the application will be ready for you. And we also have the custom plugin model, which I will talk soon about that. All right. So if we see the category, so they are broadly 4 categories for the fault: the infra level fault, application level fault, database fault, and custom fault. So infra fault means uh, failure happens at the in the infrastructure layer where your application is running. So for example, there is a Linux server where you hosted your application, and if the failure occurs to the server, there can be various type of failures. So we mimic all such failures to the server level, and in those conditions, how your application behaves. So that is the main goal for infra level faults. Now the second category is the application level fault, where and we support JVM right now. So if a Java based application is running, so in the we inject the fault into the JVM, and in those scenarios, if the application itself gets some failures, how your application reacts to those failures. Similarly, we have database level faults. So we do support right now MongoDB, Cassandra, and one more DB is there, which Postgres. So this 3 DB we support, and the custom fault I will explain into the demo in detail what is the custom fault. And we know that, as we know, like in the microservice environment, I mean, the monitoring is one of the key aspects. So to enable that thing, we do have integration with various metric providers, and um, the, the three which we have is like Wavefront, Datadog, and Prometheus. Um, so this is the screenshot I have taken from the latest version 3.0, which says the various type of faults we have. So if we talk about infra faults, we have CPU, memory, disk IO, kill process. Um, so what is the meaning of each fault? I'll tell in brief. Like CPU infra fault means on the infrastructure we will inject the high CPU load. Similarly, for memory, we'll inject the high memory load, and disk IOs means we'll run multiple IOs on the target disk. And similarly, we have disk full also. So if you mention a particular disk drive, with that fault, it will fill the disk completely, or the percentage which you mentioned. And then we have the fault to kill any process or mimic the file handler, like we open many files. And then kernel panic, we have clock skew, we have, and network partitioning also we support. And then we have various categories in infra like network, Docker, Kubernetes and all. So in that, like network specific faults like network partitioning, packet drops, packet delay, and such faults are there. Docker specific faults like we change the state of the Docker containers. In Kubernetes, we have faults like service not available, resource not ready, delete the resource. And in vCenter, AWS, and Azure, we do support three basic type of faults, which includes your networking, storage, and the change of the state of the machines. Now, in the application faults, similar to infra, we have three common faults, which is CPU, memory, and file handler. Apart from that, which is specific to application, the Java application, we have threat leak, Java method latency, Spring service latency, Spring service exception, simulate Java exception, and kill JVM. So we can simulate all these things into the running Java JVM, Java application. All right. And then, as I mentioned, we have database faults for three type of database which we are supporting: the connection leak, transaction error, and transaction latency. Apart from that, we do have Redis fault support. So Redis do have their own fault mechanism, which is Redis FI. So we are calling Redis FI for Redis related faults. So Mangle is not the single tool. There are many tools available, and Chaos Monkey is one of the oldest tool which is available in market. But from the various aspects, if we compare, there are many areas where Mangle has more advantage than other tools which we have compared. And one of the great thing which we have is the endpoints which we support is like the huge list of that. Like for example, we have remote machine, not only a single remote machine, we can add as a cluster of machines as well as an endpoint. And then we can add a Docker as an endpoint, Kubernetes cluster as an endpoint, vCenter as an endpoint, AWS, Azure, and Redis proxy. All right, so I'll go into the demo, and rest of the slides we'll see if time permits. So this is the Mangle application page. Let's go with the login page. So we do support LDAP. So I mean, Mangle has a local domain, mangle.local, and there is a default user admin. And if you add your LDAP accordingly, you can all the users will be enabled, and according to their role and responsibility, they can use Mangle. So right now we are logging with the default credentials, which is admin, and this is the home page. So first, let's see that how you can configure the LDAP for the application. So we'll go to the setting button, and here you can see that we have already added our auth source, which is VMware LDAP. And similarly, you can add the specific auth source. Here you can see all the users are added with their respective privileges, and you can add custom role as well and define the privileges for the roles. All right, so now we'll start with the first page, which is the endpoint. Uh, the endpoint which I mentioned earlier, like uh, we have various categories of endpoint, and to access any endpoint, you need to have credentials. So, for example, you can see here there are list of endpoints available in this, and so respective credentials also you have to save, and with that credential you can access the uh, endpoints. So yeah, so this is the list of that. And so for the demo purpose, it's the endpoints are already added. We'll just look into that how we can add a new one. So we'll go to edit, and see here you can space the name and add the credentials. So there are two ways: either if for the remote machine, if the password is enabled, like you can mention the password, and if not, if private key is there instead of password, you can provide private key as well. So add that credential and mention the credential here, and that's it. Like after the test your connection, if it's successful, you can add the endpoint. For Kubernetes, to add that, we need a credential as a kubeconfig file. So let's look one of that. So this is the one which we have added, and the kubeconfig file we have uploaded here and added that credential. So using that, um, you, and the namespace is one of the field which you should mention when you are adding the kube config, like Kate as endpoint. So if you don't mention any namespace, it will be like default namespace. So yeah, so that's how you add a Kubernetes cluster to as an endpoint. And then Docker. So for Docker, if TLS is enabled, then the requirement of uploading the certificate, CS certificate, and keys and all are required. If not, then there is no such credential required. So you just need to provide the Docker host where Docker service is running with the port. So default is 2375. So if the TLS is enabled, you need to add the certificates as I mentioned. So these are the certificate which you will upload and add it. And similarly for VMware, AWS, Azure, and all. So whatever the required things for to access endpoint, those are required to add it here. Yeah, so for like AWS, you need the access key and secret key. So this is the way of adding the endpoint, and these are the list of credentials which we already have. And the other section is the certificate which we have, which right now it's not there. Yeah. So now this was about the endpoints. So let's go for fault execution. So this is categorized into different categories as we discussed earlier. So let's see the first fault. These are the list of faults in the under infra. So uh, this is the way of injecting a fault. So here you can see that if you open the CPU fault for infra, in the endpoint section, it will list all the endpoints where any infra as endpoint which you have added, you will select that endpoint and then the CPU load percentage. So for example, if you want to inject around 99% of CPU load onto the system, you will mention that percentage here. And the timeout millisecond says that after that much time, the fault will be remediated automatically. You don't need to do it manual remediation for that fault. So um, yeah, that's how it works. um, So similar to CPU fault, yeah, one more thing for the schedulers. So we have two more options apart from just running it one time. We have schedules for one time where you specify the epoch millisecond time in time, and at that specific time, the fault will be scheduled. And for reoccurrence, where like you want to run the fault in a specific interval, you can choose the specific cron job by this wizard. So this is common for like all the faults. So similarly, we have memory faults. So instead of CPU, like you can see the difference here. You need to update the how much load on the system you want. And similarly, we have disk IOs to inject the high IOPS onto the disk, the target directory, and is with the specific IO size you want. And the kill process and all these faults are like uh, this is all the fault which we support. And this is the, so we'll see one infra fault for the demo purpose and one application fault. So we'll see the Kubernetes fault here. So let's let's see the service unavailable fault for into the Kubernetes. So what is the meaning of that fault is for the specific Kubernetes cluster, there will be many services running. So if one of the services is not available, then how the cluster behaves, right? So this is a very classic case of failure. So all right. So let's first select the endpoint, which Kubernetes endpoint, and then service name. There is a sample application deployed, which is Hipster app. And so you can see there are many services are running for that. And so let's select the card service and see the behavior of the application. So before that, we'll see um, the running application right now. So we'll mention card service here, and the cards. This is the application which looks like. So we'll do a demo run, add to cart, and when do we place the order? So you can see that this is the URL, and this is the checkout service, which is responsible for this particular functionality. So this is working fine. There is no issue. And so let's run the fault, and let's wait till it completes. So yeah, it's fault injection happened. Now we'll run the flow again. So we'll do add to cart and place the order. So now you can say it's not unable to load. So let's see what happened, like whatever we have injected. So we'll see the report of that. Basically we provide the details of fault, like what time we have injected, what are the details, or like uh, what was the target endpoint, and the in the granular details of the endpoint as well, what service we have run, and all these things. So so now you can see that the service is not available and it's showing the server error. So let's remediate the fault. So here, this is the option available. You can remediate by using this option. And yeah, its remediation is completed. And let's go to the application again. So we'll do the, yeah. So now it's working fine. So as you can see that so how we can inject a fault into the Kubernetes environment. So in this example, we have seen that when the service was unavailable, and how the other services reacted to that. So that's how the like developers or engineers can look to their application by failing one of the component, and like how the application behaves overall because of that. Uh, Let me take a pause here. Any questions so far which I need to answer?
Um, yes, Avinash, we have one question.
Yeah.
Can Mangle also play around with the ML and DL models for fault injection and resiliency?
So we have a one more child project which is working for the this all algorithms. So that is not public yet, but this work is also happening. And yes, if this is the open source tool, and if somebody wants to play around with that, and if they have something in their mind to use this for their algorithms, it's definitely can be usable.
Okay. In addition to this, one more. At
Yeah.
infra level, can Mangle inject faults for GPU and TPU as well?
GPU, I'm not sure.
That is work in
Oh.
progress. So we will support it as part of future releases, not as part of the current releases.
Okay. Okay, one more question.
Yeah.
Is Mangle free or there is any
Yes.
pricing involved?
No.
VMware offers
That's
support.
So you can, the support is available through issues and stuff that you can raise through the Jira, not through the Jira, through GitHub itself. and there is a dedicated team which will support any issues which will come up on Mangle. But there is no cost associated to it, neither with support nor with the usage of Mangle.
Okay, thank you. So, is there any more slides are there, Avinash?
Not slide, but the demo is pending.
Still pending. Okay,
Yeah.
fine.
Okay.
You can go ahead, please.
Okay, thank you. So yeah, so let's see one more demo for the infrastructure fault. Um, sorry, application level fault. So here also, like, there's a few faults are similar. So we'll do one Java specific fault. So we'll see the Java exception, how we can simulate the Java exception to endpoint. So we have a sample application running. So we can start that application, and so this is a Spring based application, and will simulate an exception to that application. So yeah, it's completed, and this is the Swagger URL for that application. And let's see one sample API call. So this is the plugin based, and yeah, so the API is giving the correct response. So let's inject the fault to that. Injection home there is the optional field, and then we are injecting the fault for a class, like we are using the servlet in that. So in that application, so we are injecting fault on the Java X servlet HTTP servlet class, and the method in that class is the service method. So now there are rules which we can define. So for example, at entry means as soon as the control goes to that particular method into the flow, then as soon as the call gets entered to the method, the exception should be thrown. And the other option is like at exit. So if you don't want to see the exception at entry, you can define at exit, and once the other lines will be executed into the method, at the end the exception will be thrown. So right now we'll do the at entry, and the exception is like a Java lang exception, normal exception. We will throw with the message, the custom message exception by Mangle. So we need to mention the home directory as well as the JVM process. So we'll see the what is the process name. So by running JPS command, we can see what is the name of the process. So this is the name of process is just jar in this case. So we'll mention jar here, and the port, the default port is 9091. You can mention any free port for the fault. So let's run the fault. Logon user, basically you usually by default the root user it goes, and if you have any other user which has the admin access, you can specify the user here, and tags also you can add. So let's run the fault, and yeah, so it's in progress. Let it complete, and okay. All right, it's completed. So let's see the API response now. Yeah, now it is giving 500 error code, and it is fail basically. So let's look the logs, what logs says. Yeah, so here you can see that the exception which we wanted, the application has thrown that exception with the custom message what we are looking for. So likewise, you can inject the faults for application level, and so let's remediate the fault and see whether it works fine after that or not. So the remediation is in progress. All right. All right, so now it's working fine. There is no issue after the remediation. uh, so there are a couple of more things left for the demo. I'll quickly go through that. So we have the support for, as I mentioned, monitoring tools. So in this case, we have Wavefront added, already added to that. And in this instance, we have, um, like this is the instance where, so for each fault injection, we would send the the events. So it is easier for any application or the developer to monitor what fault, like if there is a failure into the application, it happened because of the which fault, and likewise. So this is the one of the most important aspect which we should look into. So yeah, these are the events. Like recently what we did, it is available here, and it gives all the details of what service it was and everything it shows. So this is the detail about the event. This is the home page where you can navigate all the related pages from here. And the custom fault, this is one of the important thing which we have, right? So if it gives flexibility to user, if apart from whatever faults which we have provided, and if a customer or a user wants to enhance the repository and they have a specific fault, so there are two ways: either they contribute to the GitHub repository and build the Mangle and run it into the environment, or the easier way is like there is a way of developing the plugin into the Mangle architecture. So you upload the plugin and it will work as it is with the existing Mangle running application. So um, I think the time almost over. So I'll quickly forward this. So yeah, this is the way you can upload your zip file, and once the upload is done, you can use the fault injection and select the plugin here. So after the upload is done, you can do the injection as the normal other injections. There is no much difference in that. Okay. So I'll show the documentation and the public repository quickly. So yeah, so this is the page, Mangle GitHub repo, and there you can refer the code base, and you can raise the issue or you can contribute as well. And the documentation also, we have like good support of documentation. It explains each and everything about whatever I have been spoken so far. It's a very detailed documentation we have, and like starting from how, yeah, so we have like virtual appliance. If you want to use the virtual appliance, what are the steps? If you want to run as the Docker containers, the commands to run the containers, and if you run as a Kubernetes cluster, what are the steps to follow? So basically it has all the details of uh, running the Mangle application. And then like what I explained about the endpoints and the fault injections and like everything it has. Yeah,
Okay.
that's I think I
So
exceeded the time. So
we are
yeah.
just running out of time.
Yeah, sure.
So from my side and from everyone, thank you so much for this informative session. It was really great.
Thank you so much for giving the
Yeah,
opportunity. Thanks, Ashwati.
thank you.
Yeah, thanks, Avinash. And thanks all for the opportunity.
Yes, thanks, Aswati.
Bye.
Okay, so now we are about to conclude all the things. Once again, thank you to all the speakers for this informative sessions, then our organizers and the volunteers. So over to you, Ajit.
Yeah, sure. Can you hear me?
Yes, sure.
Okay. Okay, so as we close today's event, I would like to thank everyone who has been part of this journey. I know it has been a kind of a really busy day throughout the session, where we had a great speakers, great topics. I'm sure like you would have enjoyed it a lot. So I would like to convey a gratitude to few of the members who have really put a lot of hard work in making it happen, especially Apurva, Sagar, Sangam. They have been actively working since last 3 to 4 weeks time. Special thanks to Stephen, Nicholas, Vikas, even they are in a different time zone, but they came in and they delivered an excellent topic and the presentation. Thanks to Pooja, Chinmay, and Sangam for playing the game and keeping it alive. Thanks to Vinay. Thanks to Sagar, Prajakta, Avinash. I think I might have missed few of the names, but thanks everyone for making it happen. And definitely, I could see there has been a lot of excitement around the audience. We will try to bring more such conferences in future. Thank you so much. And let's not forget, stay home, stay safe. Thank you.
जो साथ दे दे सारा इंडिया, फिर मुस्कुराएगा इंडिया, फिर जीत जाएगा इंडिया। से सड़कों पे सब नाचेंगे, पटरी पे पहिए भागेंगे, गूंजेंगे खेलों के मैदान, बांटेंगे हम खुशियाँ, गम भी हम मिलकर बांटेंगे, फिर से होगी सपनों की उड़ान। दे दे सारा इंडिया, फिर मुस्कुराएगा इंडिया, फिर जीत जाएगा इंडिया। से सड़कों पे सब नाचेंगे, पटरी पे पहिए